In late January, the most potent observatory, the James Webb Telescope, in orbit reached its target 1 million miles from Earth and unfolded its intricate tennis court-sized sun protection. The scientific equipment on the Webb Telescope has been calibrated by engineers, exceeding expectations for their level of precision. The telescope is expected to ignite a golden age in our understanding of the universe by revealing images of distant space that are billions of light years away. But first, how about we brief you on the finer points of the telescope before we discuss the amazing discoveries it has made? Watch this video through to the finish to see as the James Webb Telescope is unveiled layer by layer. The James Webb Space Telescope, also known as JWST or Webb, is the largest and most powerful space scientific telescope ever created by NASA. A large infrared telescope with a primary mirror that is about 6.5 meters long is housed in this renowned observatory. Sounds absurd, huh? The James Webb Space Telescope is a solar orbiting infrared observatory that is roughly 1 million kilometers from Earth. It is used to investigate how planetary systems are created and to locate the first galaxies in the early universe. James Webb was developed in cooperation with American, European and Canadian space institutions, with NASA assuming the lead. The Hubble Space Telescope's results will be supplemented and expanded on by the James Webb Space Telescope, an infrared observatory with a far wider wavelength coverage and increased sensitivity. But are you aware of what it has achieved in a really brief amount of time? Well, the view of the Carina Nebula, a cloud of gas and dust located about 7,600 light years away, shows stellar nurseries, infant stars, and protostellar jets, which are thin, ultra-fast streams of gas erupting from baby stars. Massive clouds of gas and dust called nebulae can be hundreds of light years large in some cases. JWST's infrared camera allow it to peek into these dusty areas of space, revealing amazing details that earlier telescopes had not been able to observe. The Webb telescope obtained this image of NGC 3324, a star-forming area in the Carina Nebula. It is possible that unstable regions will be encountered as this region's boundary advances closer to the gas and dust. A new star can be created by the collapse of the gas and dust under the influence of pressure fluctuations, a process known as accretion. A star may not develop though if too much material is pushed away. The observations made by the Webb telescope in nebulae like these may aid research into several unsolved astrophysical mysteries, such as what governs the number of stars in a given location, and why stars develop with specific masses. Researchers can discover how these clouds are impacted by star formation. There are a lot of tiny or low-mass stars in nebulae, but little is known about them. But by examining the jets seen in the new image, researchers may learn how these stars are ejecting gas and dust from the cloud, decreasing the quantity of material available to build new stars. Additionally, researchers will be able to count all of these low-mass stars and take into consideration their effects on the nebula as a whole. And if this didn't wobble your mind like a maze, how about we move on to the next awesome discovery made by the Webb? To begin with, Webb has located traces of water on another planet. That's right, exoplanet WASP 96b, a planet outside our solar system, was discovered by the JWST using a spectrum of light rather than an image. Highlights in the spectrum show that there are water molecules present. The spectrum also reveals indication of clouds and haze, which were previously believed not to exist in the atmosphere of WASP 96b. WASP 96b is a gas-dominated exoplanet. It has a slightly bigger mass than Jupiter and orbits significantly closer to its star, turning around every 3.4 days as opposed to Jupiter's every 12 years. The Webb telescope provided the most in-depth view of WASP 96b's near-infrared spectrum, and the improved resolution completely altered our understanding of the exoplanet's atmosphere. Although WASP 96b spectrum has previously been recorded, the Webb telescope provided the most detailed view of it. With the use of this spectrum, researchers will be able to estimate the exoplanet's water content as well as its oxygen and carbon contents, and even identify how, when and where the planet was formed. Wait till we tell you about the next discovery if you believe these findings have been over-the-top overwhelming for you. Let us tell you about the oldest galaxy there is while you prepare yourself. And yes, it does exist. Using one of the photos, astronomers think they have located the oldest galaxy ever photographed, one that was created just 300 million years after the Big Bang and is 3.5 billion years old. Just over a few weeks ago, NASA's debut of the James Webb Space Telescope's first batch of photographs astounded the entire globe. One way to determine the age of a galaxy is to use the redshift, or the stretching of light's wavelength into the red spectrum as the cosmos expands. The stretching is larger, the object in the image is further away, and it's also older when the image is redder. After examining the deep field image the Webb telescope provided, a group led by Harvard Center for Astrophysics astronomer Rohan Naidu discovered a galaxy with a shift that placed it at the 13.5 billion year mark. "We may be observing the furthest distant starlight ever observed," Naidu has said, France 24. The next step is to submit their research for review by other scientists, who will hopefully confirm their discovery, made by none other than the James Webb Telescope. So what else can we anticipate from the James Webb Telescope then? To begin with, just be aware that this telescope will allow people across the world to see things that have never before been made visible in the history of Earth. We'll learn from the Webb whether our solar system is unusual or common. On the other hand, it might just alert us that a normal exists. Many questions remain though. How do the majority of solar systems work? Finding a planet with as much water and a pleasant habitable zone as Earth is unusual. The question is then, do our planet's gas giants like Jupiter and Saturn have atmospheres that are similar to those of other celestial titans? Well, through the James Webb Telescope we will be able to put a new perspective on our solar system. Additionally, Webb's observations will point to exoplanet researchers in the right way. Over 1,500 of these different super-Earths have been found so far by astronomers, but they continue to be elusive. Who will inform us of their atmospheres even if they do? Although we are pretty confident you already know the answer, the James Webb Telescope is currently operational and will provide answers to many whys that have never been possible before. But that's all there is for today. Please share your ideas with us regarding the next object you believe the James Webb Telescope should discover. We'll see you soon.